Today we will be solving one of the question which was asked by one of my student. The question is find the area between the graphs of y is equal to x squared plus 2 and y is equal to minus x. The bounds are given at x equal to 0 and x equal to 1. So in order to find the integral for the area, the formula which we will use for the integration purpose will be area is equal to fx minus dx, minus g of x, and then differential operator which is dx. So this formula is applicable when g of x, let's say any function is less than the function of fx. So if we have gx is less than fx, the area of the integral will be fx minus gx of dx. Let's say if we want to know, okay, which graph of which bound is the upper bound and which one is the lower bound, you can use the Desmos graphs to plot these two graphs, and you can find which graph is on the top and which graph is on the bottom. Or I can draw rough sketches for you. So the first function is y is equal to x squared plus 2, and the second function is y is equal to minus x. Let's say we use the ordered pairs for the first one, which is y is equal to x squared plus 2. Let's say I put 0, so then the value of y will be 2. If I put 2, the 2 square will be 4, 4 plus 2 will be 6. So my first point will be 0 and 2, let's say 1 and 2. And the second point is 2, 6, 1, 2. This was 2, right? 2, 4, 6. And then similarly we will have the minus x also. If you want to put minus 2, then minus 2 square will be 4, 4 plus 2 will be again 6. So minus 2, and then this point will be here. So my graph will be like this, which is y is equal to x squared plus 2. In order to get the graphs for y is equal to minus x, we will use the same procedure. We will put the values of x and y. Let's say we put 0, so the value of y will be 0. If you put x as 1, then your y will be minus 1. And if you put x as minus 1, then the value of y will be plus 1. So the graph for the second one will be 0, 0, then 1, x is 1, and then y is minus 1, this point. And then when x is minus 1, then it will be 1. So this line will be like this. So this point, and this point, we will just draw the line. So we are trying to find the area between this. This function is called, let's say, fx, and this function we denote by g of x. So definitely fx is greater than g of x, or we can say g of x is less than f of x. So the formula which we will be using is, so area will be the integral of fx of minus gx of dx, and obviously you can see this graph y is equal to x squared plus 2, which is denoted by fx, and y is equal to minus x, which is denoted by g of x. So this one is on the bottom and this one is on the upper. So my integral will be fx minus g of x. So that's the way you calculate how, or you can use the Desmos graphs and graph both the graphs. Whatever the graph is on the top, we will say f of x minus g of x. So I'm erasing all these values, but leaving the graphs. So my fx was x squared plus 2, and minus is from the formula, so this will become plus x, and then we have x squared plus x plus 2, and then followed by d of x integral d of x. And the bounds are given as 0 to 1, so one lower bound is 0 and the upper bound is 1. And you can also, if the bonds are not given, then you use these two equations solve simultaneously to get the two values of x's, which will be very similar to x equal to 0 and x equal to 1. So when we integrate, what's the integral of x squared? The integral of x squared will be x cubed upon 3. When we take the integral, what we do is we add one, which is the opposite of derivative, and whatever 2 plus 1 the exponent is, we divide by 3. So x, you will add, what's the exponent is 1, so 1 plus 1 will be 2, and divide by 2, so x cubed upon 3 plus x squared upon 2, and then the derivative of 2 will be 2x. The lower bound is 0 and the upper bound is 1. Then in the next step we will put the values of 1 as x. So it will be 1 cube divided by 3 plus 1 square divided by 2 plus 2, and then minus, when we put the value of minus, so x is 0, everything becomes 0. And then you can solve 1 cube is 1 upon 3 plus 1 upon 2 plus 2. So we can write like 2 instead of 2 upon 2 upon 1. And then the LCM, the lowest common multiplier for 3, 2, and 1 will be 6. So I multiply by 2 by 2, 3 by 3, and this 2 by 1, so 3 by 3. So 1 times 2 will be 2 upon 6 plus 3 upon 6 plus 3 times 2 is 6 upon 2 upon 1. So we will multiply this one by 6 by 6. So this one will be 12 upon 6. When the denominators are same, we can add the numerators. 12 plus 3